Hi guys, sorry I'm not there today, but it's me. Just because I'm not there doesn't mean the learning stops. So we are going to try something a little bit different today and do some video notes. So I have pre-recorded this lesson for you today, which will also be up on Canvas if you need to revisit it. But for now, if you at any time you need it to be paused, since it's just a video, please just raise your hand and ask the substitute to pause the video or rewind if needed to be, and they will do that for you. Please be respectful and raise your hand. Try not to be talking because it's hard to hear videos. And let's get through this, and then you have the rest of the period to work. You can work in your groups on our enrichment for the day. Okay, so today we're going to be talking about secants, tangents, and other angle measurements. So basically, what a secant is and how secants and tangents can form angles in a circle. So we talked about secants the last time we met, or not secants, we talked about tangents the last time we met. Remember, tangent is a line that touches a circle in one point. It's perpendicular to the radius. But then we have a secant as well. So the definition of a secant is a line that intersects a circle in exactly 2 points. So if you look at my diagram here, we have secant BD, okay, and it's a line, so we would label that BD with a line over the top. That is a secant. We also have secant AB, AC. So secant AC and secant BD. And notice both of these secants form angles inside the circle. So I've labeled some of these angles. Here's angle 1 and angle 2. We also can add 3 and 4 if we want to, but all 4 of those angles are the ones that are formed by the intersection of 2 secants. Now we can use this to find the measurements of our angles that are formed. We actually have a theorem. And it says that if 2 secants intersect the interior angles, the interior of a circle, the interior angles that are formed are related to the intercepted arc. Now remember, the intercepted arcs are the ones on the inside of the angle. So, for example, here's angle 1, and here's angle 1's intercepted arc. Since angle 1 and angle 3 are congruent to each other, notice they are vertical angles, this is also an intercepted arc. So our theorem states that if 2 secants or chords intersect on the interior of a circle, then the measure of the angle formed is 1/2 the sum of the measures of the intercepted arcs. Sum meaning add them together, intercepting arcs are the 2 arcs that I highlighted in red. So what this is saying is that angle 1 is equal to 1/2 the measure of the arc in degrees. You add arc AB plus arc DC together, and then you take half of it, and that's what angle 1 would be equal to. Angle 2, or 4, because they're the same, because they're vertical angles, those would be equal to 1/2 the sum of arc BC and the arc AD. Okay? Now we also have a formula for when a secant and a tangent intersect. So here's my tangent. Now remember, the tangent touches in one spot, and then we have our secant that also forms an angle. You see angle 1. Like the last theorem, the angle that's formed is equal to 1/2 the intercepted arc. So angle 1 has arc AB as its intersected arc. So angle 1 is equal to 1/2 of AB. If I wanted to find out what angle 2 equal to, well, angle 2 is equal to 1/2 arc ACB all the way around. And notice that arc ACB and arc BA complete the circle, so they add up to 360 degrees. Keep that in mind. Let's look at a couple of more little summary problems. So secants and tangents. can also meet outside of a circle. Okay, so here's two secants, and they're meeting outside of the circle. The angle involved, we're going to call those exterior angles here. Okay, those are angles that are outside. Okay, those angles will also involve half the measures of the intercepted arc. But instead of doing the sum, this time we're going to take the difference, meaning we're going to subtract. So if the angle is outside, we subtract. If the angle formed is on the inside, we're going to add. The intercepted arcs would be DE and BC. Remember, it's always on the interior of the angle. So if you have two secants that intersect, it's half the bigger arc minus the smaller one. Always do the big one minus the small one, okay? So you find out what the measure of the big one minus the small one is, and you take half of it, and that's what angle A equals. You could also do this with a secant and a tangent. Here's my secant, here's my tangent. Angle A is my exterior angle. You take the difference between arc DC minus BC. Once you find that difference, you take half, and you have the measure of angle A. And finally, the last one we're going to look at is when we have two tangents. So line AB is a tangent, or ray AB, and ray AC is also a tangent. They touch in exactly one spot, but they still intersect the arcs. It intersects arc BDC and arc BC. So again, if I wanted to find angle A, you take the big arc, BDC, minus the small arc, BC. Then you take half of those, and you have the measure of angle A. This starts to make more sense when we do practice. We all know that. So let's do a couple of practice.